Can you see my screen?
Yes, sir.
Yes, sir.
Okay, so we discussed up to the firewalls, the next generation firewalls, antiviruses, and the IDS and IPS solutions. I had briefly distinguished between antivirus and intrusion prevention systems. Also, I have told you that in couple of years to 5 years from now, you will see no customer is buying dedicated individually IPS solutions. Either the advanced requirements of IPS are now intermingled with the anti-APT solution that is taking care of the advanced persistence threat preventions, and or the lighter part of it, or the atomic version of intrusions, or the simple attack propagations, or not so complex intrusions. They are bundled with the firewall solutions, and virtually you are getting now these days the integrated IPS, which bundles firewall plus IPS together into a single hardware instance, and that is called as an integrated IPS, or it is also called as a next generation firewall. So this is the point up to which we discussed. Now we are moving towards the advanced access control solutions, which basically has two types of requirements. One, the user who is going to operate on the infrastructure, be it networking based infrastructure or the applications hosted infrastructure. When the users, they flow on that network or for those application access models, they basically are required to present themselves with their identifiers. And when they present themselves with who they are, then based on their role, they get the access into the application or the infrastructure they are trying to get into. For example, if we are booking a air ticket, we need not be part of the infrastructure. So sometimes that portal of e-commerce asks me to log in as a guest. So I opt for logging as a guest. Sometimes they say, okay, you can log in using your Facebook or Google or your other similar social networking infrastructure which they would like to support credentials. Which means if you are already logged in onto your system into your personal Facebook account or your personal Google account, that account can also be used to help you getting identified on their portal system, which is going to help you with these bookings. Okay. Now, what is the distinction between logging as a guest or logging along with the Facebook/Google is only that if you will log in as a guest, the same portal will not recognize you next time you come to book a ticket on that portal. However, if you log in with Google or with Facebook, so the portal of the airlines or any other ticket booking system will recognize you next time when you come on that infrastructure. So that will give you, they may start giving you loyalty points or some additional bonuses, or they might say that, okay, if you book 10 tickets, we'll give you 50% discount on the 11th ticket, so on and so forth. So these are the ways and means in which the authentication can happen in the public portal systems. But if I am an organization employee and I get into my company and I want to log in into some portal to apply for a leave, or I want to apply for some a training whatsoever. So in that case, the employee portal system has to recognize you as a part of that organization. Therefore, they will give you the credentials. The moment you present those credentials, you will be logging into those applications. All such scenarios where a user present itself to the infrastructure of application or applications, then such way of doing authentication slash use of that authentication to further authorize users to what all it can is one kind of authentication or extended authentication framework. Another extended authentication framework, which I have explained you yesterday also, is the AAA infrastructure, where the administrators, because we know that if we put a server, if we put an application, if we put a network router or a switch in the infrastructure to make these applications work for the users, somebody needs to maintain them, somebody needs to configure them, somebody needs to troubleshoot if an issue happens on these infrastructures, somebody needs to take a backup of their configuration. All such tasks, which are administrative tasks on these infrastructure devices, they need to be owned by some set of administrators. That set of administrative functions also need an authentication and the authorization. Maybe somebody is only required to do a backup of the configuration. He is not allowed to play anything in the configuration. Somebody who is a troubleshooting engineer is only allowed to look at the configuration and add new configuration tasks, but he cannot delete the existing configuration. So somewhere this way, you can actually see the different roles even in the administrator capacity keep on building in. So such levels of administrative functions, when they are uh, categorized or being customized to a specific role, that is called as an authorization function. Thirdly, once the authorization is done, since these administrative tasks are very critical functions, they can bring down the network. They can see that, okay, somebody has actually done a troubleshooting of solving one problem. While solving one problem, he has created another problem, for example. So somebody just need to undo all that. So therefore, there has to be a recording or a auditing of those actions. And that's what is accounting meant for. So AAA solutions are primarily for the administrative functions, and then there we have the user functions. But if you see that in both user function and triple authentication, AAA of functions, the first word is always authentication, which means somebody, whether he's an administrator for an administrative function or a user for an application access purpose, he or she has to present itself onto the respective infrastructure. So for that, there are variety of ways in which you can present yourself too. You have, yesterday I've told you, you can have face recognition systems, you can have iris scan, you can have finger bioprint, you can have thumb print, you can have full hand print, a four-finger print, or you can have the voice recognition. So many ways in which the authentication is given, or a full hand recognition. So all these methods, they actually form a multi-factor authentication framework, which means you will have a username, and then you will have a password, and then you will have a biological or any other equivalent factor to authenticate you. So somewhere, some systems only require a password and a mathematical number called PIN, or sometimes they will require any other dynamically generated password. So you must have also experienced that whenever you are doing some transaction on bank, sometimes, or on doing on a credit card, you are prompted the moment you reach to buying stage of a merchant. The merchant redirects you to a Visa website or a Master website or a Amex website. Therein, that websites ask you for one-time password, which they share it over your mobile number. So that is randomly generated one-time password that comes at the moment of your transaction on your phone, and it has some validity for some time. Similarly, if you are activating your WhatsApp, so you get one code dynamically generated for that phone number. Now all these are ways and means to actually validate that who you are, and you are the right one presenting yourself. So that's why I'm using, not that I have to authenticate you, you have to present yourself rightly with your identity, which means you will be asked perhaps multiple things, which at least more than one, to present yourself when you are coming onto the network. So once the authentication is there, then on the right side, you are seeing that on the network devices, you will be requiring the administrators to log in. Multiple administrators will have multiple roles. Okay. So you are seeing basically two different icons on the right side, and courtesy to cisco.com for these two icons. So one of the icons which is you are seeing in a maroon or a reddish color, that color basically has a kind of database. So which means in that database or a AAA database, you are going to create these administrators, and against each administrator you are going to define its domain of administration, which means what all devices it can control. After domain, then on each of these domain based devices you are going to assign what all tasks it can contain or do. So that part is called as the authorization configuration. So once we have configured for all these administrators, then when the administrator log on into this device, you are seeing two different people, for example, connecting to this blue color device, and there is something like a firewall shown between them. So virtually what it means is that the two people are controlling two different virtual contexts or two virtual instances which of routing or a switching or any other component which have been configured on this blue color device. So each one of them will have its own administrator who cannot see what is there on the other side. So this is how the authorization is being done. And accounting basically means that whatever these guys are doing on these blue color kind of devices or servers or application administration tasks, they all get recorded. The left side of picture is attributed to freepik.com. So it is one of their free vectors which I've used in this slide deck. Now, coming back to authentication solutions. Now, these authentication solutions, which are most typically used when you are authenticating. So we have in the beginning told that there are two kinds of scenarios most commonly. One, when you are accessing any application, so you are presenting yourself as a user. The other is that you are an administrator of some application or server or a routing or a switching device, etc., etc. So you have to do yourself, present yourself as an administrator. Now, in either case, the most typical solutions that exist today are being captured under each one of those categories, which are used for authenticating a user. Okay. So for example, in the user's case, you will require a username and substantiate it with either password and a PIN, which means PIN is a mathematical, 4-digit number. We all know we have a ATM card PIN, which is either 4-bit or 6-bit or 8-bit. So that number gets connected with my, card, and then how I get into it. But on the IT infrastructure side, a password can be combined with a PIN number. Second, password and a biometric, which means I will have my own password plus I will have my thumbprint or my iris scan or whatsoever. And in the very complex and high sensitive zones, like the sulfur chamber inside the power plant, or sorry, inside the chemical plant, or a nuclear power plant sensitive area, or in the Ministry of Home Affairs, all those guys will have maybe third factor, which is password plus PIN, and then also biometrics. So all three have to be given, then only you will be allowed to get inside the area of logical access which you are supposed to get into. Now, we all know that currently we are living in the era where the user experience matters a lot. So therefore, it is very, very difficult for application vendors to expect from the users to have their username and passwords for each and every app. So what has happened is that there are single sign-on solutions which have been into existence. So let's take some examples. If I log in into a company as an employee, and this company has, let's say, a web server, mail server, leave management server, policies of all the company, etc. I can apply for trainings. I can have an internal training. I can read the internal content. All that, what as an employee I might be able to do. All these systems will have their own individual passwords and authentication expectations. So what happens is that the Microsoft AD, that is Active Directory environment of Microsoft, it helps these different service providing systems inside the organization to get into an acknowledgement of a common framework for the username and a password. So that function is called as a single sign-on, which means the moment I come in the morning, I log in into first time into my device, giving my AD credentials. That would help me roaming inside that network every time I will be accessing any new application inside my office. Only thing which will be working is my screen or my laptop lockout, which will be only known to me. The moment I will again unlock my laptop with the screensaver password, what will happen? Again, it will just give me a similar access to all the applications. I am not required to re-authenticate every time with this. Similar way, it's not just the Microsoft environment, but various other directory services which are even in the Linux environment. So that's basically is called as a lightweight directory access protocol. So LDAP is an abstraction of authentication for single sign-on within the common domain or common forest of entities which are belonging to one single structure or company. Okay, that's a very simple layman based definition I can do. Then what is required between different apps that are not under same organization, which means it's not my employee experience alone which matters, because I'm doing variety of other work as a user, as a netizen. So when I am booking a ticket and that ticket booking portal asks me that I can recognize myself or I can introduce myself by my already logged in credentials of Facebook or Google or anything else for that matter. So what does it mean? It means that when I am going into an application, let's say Zoom, and therein I have asked Zoom to actually go to validate my credentials only on my Google as a mail credentials, and once if I am already logged into Google, don't ask me a password, just give me a access on Zoom as a Ramandeep Singh @qstechnology.in, for example. So that means Zoom, which is a different company, has to trust the authentication which Google has done to this user. So how will this happen between Google and Zoom? That framework of authentication is called as federated identity management, which means the federator federates the other underlying body that, okay, if I authenticate, you can use my authentication credentials. So in this case, Zoom is blindly trusting what Google is authenticating. But do you think vice versa is possible? No, because it is highly likely that in the current scenario that every user who is accessing internet will have at least a Gmail ID. This is highly likely. But the same population of people, if you will do a survey and you ask them that how many of you are using Zoom, hardly you will find 10% of them are using Zoom. Therefore, the credentials of Google are more powerful. So which means other application vendors or other portals can actually trust Google because more people are authenticating themselves to Google than onto them. Okay, same is the case with the Facebook. So Facebook is also a very popular application. Almost 80% of the number of people, this is my understanding until last year, so maybe today almost Facebook might have 7.8, 7.5 billion of accounts. But if I look until last year, they were having almost 6 billion or 5.8 billion accounts. It's a huge number. So Zoom is not going to have that, or my portal on Make My Trip will not have that, or my portal on hotels.com will not have that. So that's why these vendors will allow you to federate between the applications. So that's the federated identity management. The same framework also works between the organizations. So if, for example, you are a part of a checkpoint partner map, because maybe as QoS technology you will get a credential there, and checkpoint tomorrow builds an alliance with another company called let's say Clarity, and they would want to give a better user experience to their partner map people. So there is a possibility that Clarity starts federating for the authentication with checkpoint, which means the moment you will be logged in already on checkpoint partner portal and you go to Clarity's website, there is a likelihood in the case they both will have a federated identity management framework established between both of them. Then the moment you will go on to the Clarity partner portal, you will be recognized there without being asked to re-authenticate yourself. So this is what is the single sign-on solution which exists on the authentication frameworks. On the administrative sides, the very oldest generation solution. So all these uh, letters which you are seeing on the right side of the screen under AAA category, whether it is Radius, whether it is TACAX, whether it is PIM or PAM, these are all abbreviations. So all of them have their respective expansions. So you can see and Google it to find out what are these. So in generation 1, authentication was primarily radius based authentication. It was pretty simple, but then the encrypted authentication and then more complex granular authorization was possible when TACAX was introduced. So TACAX is a generation 2 solution, and now with the amazing capabilities of supporting even the federated management and other features, smart features, the administrative level AAA solutions are now being classified as payment PAM. So what are payment PAM? What I mean by that federated management solutions are even supported here. It means that if suppose company A and company B both are the some kind of alliance companies with each other, and they both hire QoS technology as their support or services partner for some specific security infrastructure and operations. Imagine they might put a payment PAM which will start recognizing the credentials once the users of QoS technology are authenticated on Google portal of QoS technology. So something like that is also possible with the current generation PIM-PAM solutions for authentication part. Okay, so most commonly people are using PIM and PAM of current solutions. Okay, now we'll move on from here to the next category of solution, and that is the DDoS. So distributed denial of service attacks, these are very common attacks of current times, and they basically are of various types. One most common type is basically they create a flood. They create a flood of illegitimate or unwanted traffic, so that actually they can hamper the access of the legitimate users. So that's the fundamental way of doing this. Most of the DDoS people will have some notions, something they have in their mind why they are doing that. Nobody does a DDoS just for no reason. It will have some very specific objective, either state sponsored, or it is based on financial gain, or it is based on competitive sponsoring, or it might have various other objectives. Apart from low and slow, apart from flood attacks, there are some low and slow DDoS attacks also. So what are these low and slow DDoS attacks? These are multi-stage attacks. So in the stage one of the attack, they are never flooding anything. They will only try to sneak into the infrastructure, and then they will go inside the infrastructure, and therein they will immediately amplify themselves, or that's where they will detonate themselves. And on the detonation, it will become a DDoS attack on their machine itself. So for example, in the stage one, they will be using a virus or an exploit to intrude or to hijack the system. Once they hijack the system, which means they will plant themselves, they get into the infrastructure, and now they will start generating lot of traffic inside that machine. That will kill either the CPU, or it will start loading the memory space inside that machine. Though there is no flood on the network, there is no flood on the wire, but this machine will start seeing its CPU or memory or both start shooting up from a normal range of 20 to 30% towards 90 to 100%, which means the only way to get moving is to restart the machine. So this is what is the objective of low and slow DDoS. And last but not the least, the DDoS are also current generation DDoS. They are using the botnets or the zombies network. And we have already discussed virus bots intrusions in the previous session. And we have also discussed that when a bot is there, it means that some machine is compromised and is in the control of some hacker who is sitting outside. And that controlling hacker is called as a C and C. C ampersand C, that is command and control. Or you will see C and then English A and D and another C in the capital. Okay, so that's also command and control. Or you will see in a very slang language, C small n. Small n means N for nest, and then another capital C. So that's like in a slang. Again, that also stands for command and control only. Okay. So these command and control guys, they will control their bots, and these bots will actually generate too much of traffic against a bank, for example, or against a telecom company, or against some service provider or an e-commerce site, which means the attacker is not directly attacking the person, he is using some other bots to amplify its attack. Secondly, every protocol which these guys are using, the bots or the zombies, it will have some factor of generating additional traffic. Now hear me out, this is very, very important, and that factor is called as an amplification factor, which I'm going to explain you in next 1 or 2 slides. So just from an overview perspective, for a DDoS, we need to understand that DDoS will very commonly be depicting the flood attacks, in the network, where the illegitimate flood will affect the servicing of to the legitimate customers. Secondly, it will have some notion. Somebody has an objective. Attacker will definitely have a financial objective, or a competitive objective, or a state-sponsored objective, or a hacktivism. Hacktivism is basically when you are seeing that people are doing some kind of agitations, globally or in the country or in some specific sect of the community or country, and they are being targeted. Now, targeting the infrastructure or the government or any other people who are actually on the other side of the line of their activism. Now, when most commonly, if we see what are these DDoS attack types, the DDoS will attack application. So it might target HTTP, it might target SSL specifically, or it might target maybe internet banking applications, or it might target loan applications, it might target some specific e-commerce applications. Then it will target the network itself, which means without any reason to bring down any specific application, they will try to bring down every part of the network of that target organization. Fourthly, the hackers, they target the DNS infrastructure itself. So for example, if the DDoS attackers want to harm the internet access for the world, they will start hacking the DNS infrastructure, so that the DNS infrastructure is affected and everybody across the globe will see the slow response in the DNS resolution from a fully qualified domain name to an IP address. So all these are typical examples of the common day which are there for a DDoS attack types. Then we have to understand a reflex attack. DDoS attack gets complicated when it is a reflex attack. Now in the reflex, we all know that DNS is being used to do a resolution where there is a browser will go to a DNS, and DNS is the intermittent device. It is not the end objective. Just go back to the example we have seen many days ago when we were going to www.abcbank.com. So this browser only wants to go to abcbank.com. There is no other objective for this browser. But without the knowledge of that browser, or without user actually seeing that, behind the scene, that browser had given a request to resolve abcbank.com to a respective IP address, and that's called as a DNS system. So if the DNS does not exist on the internet, let me tell you, a browser will never be able to go to abcbank.com until and unless he himself knows the IP address of abcbank.com. And we don't remember each of those, billions and billions of websites today existing on the internet. We can't memorize, or our systems cannot memorize their respective IP addresses. So therefore, there is a definite need of DNS to be in existence. So there are third-party hosts. So this is called as a third-party service provider. Similarly, there is something called as a NTP, Network Time Protocol. We all know that every country has a different time zone. At least most of the countries will have a different time zone than the other countries. And if a browser is sitting in one country and the server is sitting in the other country, they are trying to do some transaction will have a timestamp. If the time synchronization to the respective time zone and the correct timing between these two has, for example, if there is a jitter in the time, there will be an unlikely or an unwanted, unsolicited delay that might actually bring down this transaction, because they will say that this is out of time. So there is a synchronization which is required at the country level for the timers, and that timers are then giving a common input to all these different servers, routers, switches, machines which are connected in the data center. So that service which is globally working is called as NTP, Network Time Protocols. There are millions of NTP servers that are scattered across, which are themselves first of all synchronized, and they help the different countries, different systems, different infrastructure requirement components to get synchronized with that particular time, so that all have the same timestamp. Then there is something called as SSDP. So this SSDP is used by the service providers to manage their broadband routers. So we all know that let's say we have telecom provider A, B, C, D in the country. So we would have taken a broadband from any one of them. And for that guys, that service provider who has thousands or millions of broadband subscribers, they have to manage their IP address, they have to manage their device on a real time or a dynamic basis. So that functions of giving those dynamic characteristics is basically a feature called SSDP. So which is with the service provider, okay, who will be using this protocol for entire set of their broadband users. So there are similar way multiple such protocols which are used. Each one of these protocols also have a amplification factor, which means when a browser send one single byte to a DNS respond with average 79 bytes. Okay, this is what it means. It means a browser will send only 1 byte of traffic, but the DNS server will respond with 79 bytes as an average. Similar way, a NTP instance or a service request for NTP will send a single byte and it will be responded by 300 bytes. SSDP is the heaviest. A SSDP broadband router or a broadband device will send 1 byte, for example, and it will be responded with 4,000 bytes. Just imagine now, keep this in mind. Now, this is not that I am defining these numbers. These were defined by a university in London in 2015. They have done research and this is what they have brought and shared that research, which is now more or less globally accepted. So what is the third phase? So there is, first of all, we have understood that there is a reflex which is happening because there are a third party involved, which is not required to be in our actual client server, but without the third party coming into the network flow somewhere without the knowledge of the user, the application flow will not be complete. So that's the first thing which we have understood. So in the DDoS reflex actions or attacks, this is one characteristics which is being exploited. Second, each one of these third party applications have an amplification, which means you send them 1 byte request, they will be responding with multiple number of bytes in the response. This is the typical technology behavior. And the third thing is that the attacker is going to combine all these with a very interesting feature that he plans the attack. He collaborates people to launch an attack without our knowledge. So he or she will always have a asymmetric advantage. Okay, so when all these are combined together, this is how we are going to get now. Let's see this. Okay, so this diagram shows you a command and control hacker in the green color on the top of that red window. All that guy has now is a control of these desktop users, mobile. So you can see that there's somebody is a mobile user, some of them are desktop laptop users which are spread across on the internet. All these command and control guy can do is he can control these bots any moment. When he control these bots who are already his infected users in the step 1, the botnet will be in his control and he will say all these guys, he will take a control of their browser without letting these users know, and in that browser he will start crafting the packet. Let me tell you, he will craft the packet. Once he or she has crafted the packet, what it will tell to that crafted packet, that in the source IP of your machine you should change the IP address. Don't let your packet move out of your wire with the source IP as you. What you should do, you should spoof it with the victim's IP address. So let's say my victim is mybank.com and this mybank.com has an IP address 34.97.53.119, for example. So what this command and control will tell that even if your source IP is 111.55.xyz, to all these guys respectively, each one of them will have randomly different IP address at this moment. To all of them, it will craft a packet with a IP address that is starting with 34.97. dash dash. That is of a victim IP address. So now what these guys will do, in the source packet, they will put the IP address of a victim, not themselves. And in the destination, they will send a packet to the DNS. So they want to go to the DNS, and all will send some DNS request. Somebody will say, okay, bring me www.facebook.com, bring me www.google.com, bring me www.gmail.com. So randomly they will send these packets. But all that DNS infrastructure knows is that all requests have come from 34.97.xyz. That is my victim IP address. So what will happen? The entire DNS will start sending responses to this victim. Now we know that first of all, there are hundreds of queries which have come. Why? Because there were hundreds of bots which the command controller was controlling. And then we know that the DNS itself for one query is going to send, let's say, 79 times more traffic. So if the query was 100 bytes, he is going to send 7.9 kilobyte of data back for each request. So if there are 100 such requests, what does it mean? That the customer is now going to see almost almost 1 MB of traffic. And if 100 such queries come from each one of them, this will become now 79 MB. So imagine if my internet pipe is just 2 Mbps. This DDoS will kill my entire internet pipe, because one of the victims sitting inside my infrastructure called mybank.com is now becoming a victim of this DNS responses which are coming. So this is how a reflex attack happens, which uses the third party called DNS in this case. It uses botnet on the right side, so it is multi-stage. In the stage one, it is just a botnet attack. Third, it uses the amplification factor, because each of these third-party protocols have an amplification. All of you must have heard something about 3 years ago called Mirai botnet. Mirai botnet was a attack of 1 terabytes on the service bot, because the botnets in the control of command and control were no more the phones or the desktops, but the IoT devices. Then I'm not sure if you guys have heard about a DIN attack, DYN, on the internet, which was to the scale of 700 GB, which is about 300 GB less than a terabyte. So when a 700 Gbps attack happened, that DIN attack was using the protocol SSDP, which we have just seen has an amplification of 4000. In a nutshell, if you are a SSDP attacker, you only need 1 Mbps of internet to actually generate 4 Gbps of traffic on somebody. Let's do a simple maths. So if you are doing a 4 Gbps of traffic, we have seen 700 Gbps. So let's say for simplicity reason, let's take it was 720 Gbps of traffic. Divided by 4. 720 divided by 4 means 180. It means an attacker has to only compromise 180 broadband routers to launch a 720 Gbps of an attack. This is the power of amplification. Okay. Now let's start summarizing what we have learned. This was the diagram which I have shown you in the first session. A simple network for an enterprise, which is small to medium size enterprise. It will have few clients, a Windows AD environment, also having a Wi-Fi hotspot for giving the access to the people in the company who come with the Wi-Fi readiness, and they are hosting some applications inside their servers. That servers are the physical servers stacked together and running the VMware ESXi. Then they had a layer 2 switch which is connecting all of them together, and from this layer 2 switch they are going to the router, and from the router towards the wave division multiplexer modem or a MPLS modem, and then they are going to the internet. And the external traffic from outside will be brought back again in the same way towards this organization. When we are looking at this infrastructure, there is another way of classifying the security controls which we have seen in the past. So until now, we have seen them or worked with them as the header security controls or the data payload security controls. Another classification which exists in the market today is that we are going to use them in a different classification methodology. So one of them methodology says that network security controls, which means the security controls that will be deployed by and large at the level of router, layer 2 switch, etc., the ones which are going to actually inspect the traffic at the network layer, those are called as network security controls. The ones which will be deployed on the client side machines or the Windows AD machine, which is going to service these accounts internally on the VMware based infrastructure, which is hosting lot of service applications for the internet based users or my own users. All these will have the security controls. Now, I know that on a Windows client or a Linux client, you can install an antivirus. You will install a next generation antivirus, which we have learned. You will install also some applications which are required or application security controls which are required based on the different applications you would have installed on the machine. Maybe let's say a browser security. But if you look at a VMware ESXi, which is hosting your server compute or your server side of applications, therein now, since it's not just the operating system which you will secure by antivirus or the next generation antivirus, which you any which ways have to do for that server operating system, but there is one hypervisor which has come. Now this hypervisor is not like a router or a layer 2 physical connection which you will break and bring a new network security device and will start monitoring it. This hypervisor is a logical layer inside this physical hardware compute. You don't see that physically out. So therefore, you will be introducing something called as a hypervisor security also in this environment, which is part of the endpoint security control. Okay. Then we have understood that apart from hypervisor, today the applications are moving between the development and the production. So some of the servers in this VMware will be part of my development of application lifecycle, and some will be actually in the production servicing my customers on the internet. When they get in the common hypervisor environment, it basically also requires them to talk to them each other so fast, because we are moving applications and development into a overlap cycle called DevOps. So they need to have some kind of a DevOps security or a container security. Okay, so all this is part of the endpoint security. Then we know that my server may also have my customers database. Imagine we are into a fintech business. So we are taking the Aadhaar card data of my customers. We are taking their PAN card data of the customer. And by IT Act 2000, amplified with amendments of IT Act of 2008, forces me to keep my customers' data safe and secured. So therefore, I need to ensure that some of my own employees in this company or some user who is sitting outside my infrastructure, or a hacker who will try to target my infrastructure should not get a unsolicited access of this database. So therefore, we will have to enforce some data security solutions. These data security solutions are called as data leak prevention solutions or data loss prevention solutions. And also, in the event of any loss happens, then I am supposed to give my loss input or understanding to the central government body called CERT. So I have to inform them that there is a data breach which has happened because of my infrastructure. Then they will ask for a lot of forensics data. They will ask for investigation data. So in that scenario, we should also have some capacity to see how all the data breach had happened in my organization. Hence, the data security solutions are required to augment my network security and endpoint security requirement. Last but not the least, we all have understood that the users and admin security, they come as a fourth category. So this is another way of classifying just the security here. The third way of classifying the security, which we used to read in 2000, and you might see that old books, if you start reading those books or the books which have a reference of historical understanding, they will talk to you in different way of starting. They will say there is a CIA triad. Okay, so there is a triangle of confidentiality, integrity, and availability. So in the confidentiality, you have to ensure that only right set of people are accessing the data and there is no data loss or leakage. So all your network access control solutions and the data loss solution protection solutions will be coming under them on this category, confidentiality. And then integrity. Integrity is that you have to ensure that the data which is stored in your organization or the data which flows over the wire, it is secured. Nobody has access to that data and modifies that data. So most of my network VPN solutions, network security VPN solutions, they will come under this category. Or the data which is stored in the storage, I'll have to encrypt that. So storage encryption is beyond the scope of this round of sessions of security. Okay, so storage encryption is going to be covered under the cloud security, because when the storage has moved out from my data center and is staying in the Amazon cloud as a S3 bucket, how I am going to secure that? So there are variety of techniques and technologies which we have to discuss in that spectrum. Okay, so it's beyond the scope of this solution, but you need to know what all comes under this. And then obviously the availability. Availability means that all the infrastructure has to be made available. So primarily the anti-DDoS category comes under this. But if you see this category of CIA triad, it appears to be very, very old. In the era when the generation one kind of solutions only existed, that you had a network access control, you have an antivirus, you have a VPN, and you had anti-DDoS. That's it. So all those were getting classified in this. But since you come across some approach paper or some white paper or some book which will start with CIA triad, I don't want you to guys leave it there. You may be able to correlate it, but it's not of importance right now, because this has evolved itself to now something called as a cyber resilience engineering framework. It has become very complicated. Okay, the triad, which is a CIA triad, is right. If you see it on the right side of the screen, is just the middle triangle, the central triangle, the vertices of the triangle which are there on the three edges of the bigger triangle. Okay, so that triangle is the triangle called conventional cybersecurity. That is what is represented by CIA triad, but the other security controls have moved in the different other triangles. So this larger triangle called as cyber resilience triangle is what we are going to discuss in our SOC session. So I am parking it here. Okay. The reason of this slide was only to have a historical context. The most important slides are so far whatever we have discussed, or this slide. Either you are going to classify the security in a header and a data security controls, and you should understand them that way, or you are going to use this classification, which is network security, endpoint security, data security, or user security. No customer is going to talk today CIA triad. But let me tell you, when I started my career in cybersecurity, we used to give this as a CIA triad. So there were three vertices of a triangle which were shown, and they were shown as confidentiality, integrity, and availability. So if you will see my presentations which I created in year 2000, 2001, 2, you will see CA triad has been talked and discussed for at least half an hour. Okay, so that's the reason of putting this. But we are going to discuss more interesting, not the CIA triad, the cyber resilience architecture, which has a center as CIA triad. Now, the last slide, you must be seeing some difference now here from the previous layout which we created. You would see that I have introduced a new device between the VMware and the layer 2 switch right in the bottom, in the pink color, internal security gateway. Can you see that? Any one of you can just say yes.
Yes, sir.
Yes,
Yeah,
sir.
great. Thank you. So this internal security gateway has been introduced with the functionality of a firewall and an integrated IPS, next generation firewall. All the terms which we have used so far, we're going to show you now here. Now, why is this being introduced? It has been introduced because the IT Act of 2000 and 2008 wants me to ensure that the database of my customers is safe, even from my internal employees. That's why you are seeing an internal security gateway. Apart from database, it is also having a lot of other applications which need to be secured from a basic intrusion functionality, which means one should not get compromised from an external or my own internal employees. So that's why there is a additional integrated IPS function. So this is a one appliance which has been introduced in the flow of the data. Second, you would see the appliance that has been connected to the router. So earlier the router was directly going to the layer 2 switch. Now you see that the router has been rewired. Its internal cable is now going and getting inside a device called NGTP, next generation threat prevention appliance. And then there are, instead of just one wire which was coming to only layer 2, it has got now additional one more wire which is going to Wi-Fi. Now what does it mean? My Wi-Fi is also now directly not connected to my layer 2 switch. Wi-Fi people who will bring their laptop or a mobile, and they will be using that at their home or on their own service provider network. The moment they will go out of my enterprise, they will be going to all the places which I will not be able to control. Therefore, when they come back and connect to my infrastructure, I have to seclude them. I have to segregate them or separate them. That's why you are seeing a third wire. So this way, the new network security device called next generation threat prevention appliance has been introduced. Now, next generation threat prevention appliance is physically one device, but it will have all the access control and deep packet inspection solutions. Access control means it will have firewall, it will have URL filtering, it will have application ID based security. Then it will have a deep packet solutions like an IPS. It will have an antivirus. It will have an anti-bot. All functions have been integrated together. as different engines on the single hardware. So if you would see that more or less the header security and the packet data payload security controls, more or less they are good for understanding a solution. But when I go to my customer site, I would see them either as a network security solution or a endpoint security solution. So as a technical guy, I would still need to classify them, categorize them as a header security solution or an extended header with an authentication security solution or a payload packet security solution, because that's how I will technically understand them. But when I go and start talking to my customers as a consultant, more or less you will be using a network security control or an endpoint security control. Within the endpoint security control, additional security controls have been introduced, like a hypervisor security control or a container security control. Or you will be seeing, okay, how to protect my data structures or database or my files and folders inside that system. So that's the data security controls. And then the last one is the authentication and auditing accounting controls. So this is the convergence point of your knowledge when you are going towards the customer. So when I say the raw knowledge is the way we have understood header security, the deep packet security. But the applied knowledge which will be used for the customer will be more like a network security, endpoint security, within network endpoint hypervisor security or container security, and then on the levels other security controls which we have discussed. In this particular slide, I am not talking anything but only network security right now. Okay. Apart from that, the solutions which we have not discussed too far are the VPN solutions. VPN is basically a virtual private network which extends my infrastructure to my own employees over, or my third party customers, or my third party collaborating or alliance companies, etc., etc. All these guys, they will be not part of my wide area network or my local area network, but they will be reaching towards me using internet as a carrier. So such a infrastructure is called as a VPN. Now, how are they different from just anybody accessing my website? Because anybody accessing my website is only a consumer. They are not contributing to any part of my business except for buyer and seller relationship. But our employees, our third party vendors, they are contributors. They are part of my business ecosystem. Therefore, we may need to give them more than just a browser access, a kind of a continuous channel in which they can flow the data in either direction. So there are two types of such VPNs which happens. One, IPsec. It's an old technology. Another one is IPsec. Further, there are two parts: site to site, which means a small business entity. Let's say you might see a telecom. Each of the telecom provider, they have their calls. They have their outlets in your market, in your city, in your village, in your township. Now, when they have that market, there are 4 or 5 people who are sitting there. Those people might be wearing the same jackets or the t-shirts of the company of telecom, but if you ask them, are you an employee of that telecom company, they will say no on most occasions, except for state, maybe BSNL, but most of the other ones, you will see that they will say, no, we are not the employees. But then how are you connecting? You are a third party, that means. Yeah, they are a third party. But there are 4 or 5 users sitting in that shop who connect to my telecom as my business, and they need to continuously working. So in such case, when 4 or 5 people are together and they are connecting with me and they need to work together on different requirements of the same telecom service provider or a similar application, they will connect a VPN tunnel which is called as a site-to-site tunnel, using IPsec as a protocol. The other possibility is that all four will be given a VPN client by the same telecom company, and they will install the client, they will give their own credentials, then each one of them by one will create one tunnel each. Now the only problem in the previous scenario of site to site to a client to site tunnel is that in site to site tunnel the bandwidth requirement will be little less, because you have one tunnel and in that tunnel everybody else is sending a together traffic, so there is only one encryption layer. But when all four will create their own respective tunnels, so there is an additional tunnel overload which is coming from each of those connections that will get multiplied by 4 numbers now. So that's the only difference. Otherwise, technically, they both are doing the same thing. But whether it's a site-to-site tunnel or a client-to-site tunnel, there is something required in this remote office. Either a client is required or some device which will be configured with the central telecom site, in this example, to create that tunnel. And in this tunnel, the data will flow encrypted subsequently. But imagine the kind of help desk requests or the support system the organization has to put, because this has to continuously run. Every 10 day, they come at 10 a.m. and go up to 8 p.m. So until those hours, this tunnel has to be up, either from a single as a site-to-site tunnel or all machines having client-to-site tunnels going up. In such scenarios, there is a lot of support help desk required, because it can come down, troubleshooting would be required, which has to be maintained by the service provider. To avoid this or to move faster, the organizations have evolved to something called as a SSL based tunnel. Now this is just a browser based. So all these 4 machines will no more require any client to be installed, to be configured. They just need to do a browser. They just need to give a URL which is as good as sslvpn.mybank.com. Now this is different than www.mybank.com, because if I am doing www.mybank.com, it means I am going for internet banking services. But when I will say sslvpn.mybank.com, that means I am a loan service provider for the bank, which means I am generating loan requests as a third party business entity for this bank. So I need to have a SSL access to their different business applications internally. Okay. So this is how it will work. And my browser only will set up a SSL tunnel. Apart from that, in the data security space, we have to prevent the data from loss. There is a network level data loss prevention solutions which are there. And also at the endpoint, also the endpoint DLPs are there. Okay, so you have a network DLP and you have a endpoint DLP. Then what if I lose my laptop, or what if I lose my pen drives? It might have happened with many of us that we would have put in some important content and I have lost that pen drive. Now, if this pen drive gets into somebody's hand, the confidential data is in his hand. So we need to have a media encryption or the disk encryption. Disk encryption is relevant for laptops, and media encryption is relevant for all this media where we use the data to move from one machine to another machine. So there are technologies which are there. Then the document. Now imagine somebody has a very critical document which is talking about the confidential information or the business results of the next quarter. And I am a private limited company, which means I don't need to give it to my shareholders. I just need to be internally separate, putting it to one of my board members. So when I give this document, one of the board members by mistake pushes this document to somebody else. Now that means my knowledge of internal board meeting is now in the public domain. But when you do a document encryption, the creator owner of this document, which is a boardroom meetings minutes, etc., he will encrypt the document and he will give access to only 4 people. So which means even if the document is lost or by accidentally mailed to somebody, it will not be able to open that document. Or for example, if this director is now being asked to move out of the board. He's now going to be a normal employee for whatever reasons. Then the moment his role changes, he will not be able to access his document. So that's called as a document level encryption. Then we have a database which is accessed by our customers, by our employees, etc. So we need to protect that database through database access management solution, which means who all can give what kind of queries to the database. Because if the database developers start writing the program, they can generate any kind of query which can bring in data out to them, because they are developing the database applications without the knowledge of a security administrator. So there are some database access management solutions called as DAM. Then there is a database slash data warehouse security. Now I have given you one example of a telecom and Aadhaar card, etc. And somewhere yesterday we were discussing that there is a gas company which needs to give me a gas connection, and they need an access to my credentials. So I will share my credentials, that this is my name, this is my address, and this is my date of birth. Only these three things I will give them, because that's what their form requires. But now gas agency has, because we have a subsidized system in the gas in our country, so they need to validate my credentials, because I should not be creating a duplicate entry, which means I should not be going for to have more quota on subsidy. I may not be applying with two different names or name with two different date of births. So they will validate with the centralized government's database called Aadhaar card database. Now when they go to Aadhaar card database to query my things, Aadhaar, because is maintaining variety of other information, it has all the data of my bank accounts, it has all the data of my fingerprint, it has the data of my PAN card, etc. Now Aadhaar should not give that fields back, instead of only the fields which are required to be knowing for these guys. So how do Aadhaar, which is common data warehouse, should be able to protect is by masking those fields which are not important for the bill. So they will need those masking solutions for the fields which are not relevant. Okay. See guys, these understand, these are very complex and the current generation solutions, but your customers might be talking that I'm just giving you a glimpse of this, but you have to individually research them, because they are very, very vast. Each one of them is itself is a session of 7 to 8 hours. Okay, these are just being captured for your reference. Then the last category is the file integrity monitor. So we know that when I told you somewhere I'll explaining antivirus or viruses, that viruses may be multi stage. They metamorphose. So when they metamorphose, what they do is they start as an exploit, and then they move into the next stage where they're dropping files or they're modifying the existing files. So you would need, in the antivirus category or next generation antivirus, another category of solution as an embedded function called as file integrity monitor, which will ensure that the file system is not being played with. This is how, when all of these guys, okay, you can click the photo of this, because you have to understand yourself now. So whatever we have done, this is how a typical ABC bank would look like now. So I will run it quickly fast. You will see one branch office in the bottom. It has an ATM, it has a kiosk, it has some teller, desktop, manager machine connected on a layer 2 switch, then going on an MPLS, going to the MPLS cloud. Like this branch, multiple other branches, or a loan branch, or insurance and bank call centers, they are all physically, geographically scattered, and they will come over a MPLS, which will go, MPLS will this time terminate on a DWM. From a DWM it comes to the router. Just see that router on the somewhere in the center of the slide. That router also has the RBI link, because RBI has one-to-one link, which is because this, let's say, data center of the bank is within Bombay. So RBI has a RF link given on a 16 Mbps pipe on in the setup. And then on the right side, you will understand that yes, I have shown you a very, very big layer 3 switch cluster, Clustering is only for ensuring the redundancy and high availability. And different color lines, you can see either it is 100 gig, 40 gig, 10 gig. So whatever we have learned so far, I've just tried to put everything on this machine, sorry, this diagram. And then on the right side in the center, you are seeing a server center. All the servers: a core banking server, internet banking server, mobile banking server, loans and treasury server, payment gateways, all have been put together into the racks with the physical servers stacked together. And this is coming on an internal firewall now. Correct? We saw some internal firewall in a smaller diagram. So that internal firewall is just connecting this, because this has to prevent my all these core business crown jewels. And then they come onto the same NGTP, that is next generation threat prevention server, which is bringing itself to the router. The same router is also having connection to internet, RBI, as well as MPLS. So this is how a typical bank looks like. You can read this, you can keep this. When you go to today's bank, they will internally be having this. The only augmentation which is now happening is that they are bringing cloud onto this, which was beyond the subject of this particular series of discussions which we have had. If you look at a telecom side, this is how most telecoms infrastructure look like. So why I have taken bank and telecom? Because these are the most complex infrastructures. Now most telecoms in the country will have three businesses. They are servicing enterprises, they are servicing broadband users, they are servicing mobility users. So most mobility user infrastructures, they connect to a device called GGSN. Then there is something called as a carrier grade NAT. And then from a carrier grade NAT, they come for URL filtering, and then they go to internet like this way. Okay. Similarly, the broadband and the enterprise infrastructure comes via MPLS cloud, directly getting into their respective locations. The locations which you are seeing, Chennai, Delhi, Mumbai, they are being hypothetically taken. These are the internet pipes which are going towards the internet. These are multiples of gigs. So somebody may be having, so there are somewhere, some telecom service providers even have a terabyte of pipes. Okay. So these go to two things now. The next peer in the internet chain, somebody is going to Singtel, Singapore Telecom, somebody is going to MCI, somebody is going to AT&T, somebody is going to Verizon, so somebody is going to Tata Communication. So this is the way this service provider will connect to the next peer, who will take them further next into the internet. That's how the entire internet is interconnected. But we all have now started streaming a lot of data. And when we are streaming a lot of data, Google, Facebook, Akamai, Netflix, all of them have started putting their caching server inside these service providers itself, so that every time data request for downloading the same movie does not hit the internet and choke the internet. Okay. That's why sitting in the work from home, you are able to stream movies with so many people now putting load onto internet, because there are a lot of streaming servers. The load is not going to internet, but is going to this infrastructure which you are seeing for streaming. Okay. Now the reason why I have shown you this diagram also is for one very important device which we have not discussed so far, but you guys have to understand, and that is the tap. Now if you see in such a very high end, where multiple gigs of traffic or terabytes of traffic is flowing, you can't just bring a network security device and start inspecting traffic, because nobody will allow you. But you need to still have a situational awareness. So what people do is they tap the traffic, they tap the fiber. Tapping a fiber means they will tap a 40 gig or a 100 gig fiber through the very smart taps. And then on the tap, we will put these sentries. Sentries are detection devices. So they will keep track of how many bots are flowing, what are the viruses which are flowing, who are the source of this. So they are like a surveillance cameras. Because at this stream of traffic, unlike the bank, where you could actually come in the line of the traffic flow, here the service provider cannot come. So that's what I wanted to show, the distinction between these two. So when you meet your customers, or either as a technical guy or a consultant, or you are sitting and designing a smart city security solution, you have to realize and understand that you will either see a enterprise class of solution, which you have seen in the previous slide, like with a bank example, or you will see a service provider network. These are the only two flavors. Now the scale of enterprise security might get scaled down to the first image which we saw, for a small company. So these scaled down versions or a scaled up version of enterprise security gets classified under enterprise security example and the telecom security service provider example. Okay. Last but not the least, we are not going to explain this slide. All that security controls and the network security controls that we have put in so far, all will be on the left side of this screen, and they will generate lots and lots of log. The next opportunity which is there for security engineer is how to analyze these logs, how to make sense out of these logs. And this is what we're going to start in our next session, when we are going to meet next on Friday. And that's going to be a 3-hour session on security operations center. Now we have put in all the network devices, we have put in all the applications and server hosted devices. We have deployed all the level of security at the network and the endpoint level. Tomorrow's day is for you to go research, understand all the endpoint security solutions, so that when we come back to the Friday, we are discussing how to now make sense of so much of stuff we have put in as a security providers. Because in the QoS company, not only so for whatever security controls we have deployed, we are doing that work alone, or we are not doing just the vulnerability assessment or penetration testing or DDoS security solutions, but we are also providing the security operations center, that is SOC solutions. So SOC solutions will start from here. So whatever we have done so far, how we are going to take it to the next level of cybersecurity is what we are going to talk about in next session on Friday for 3 hours. This is the slide. Don't look for all this. We will be starting to discuss from here on that given day. Thank you very much, and I hope you guys have enjoyed the session. You can send me one-to-one queries because we have already overshot the session time. I know it was quite a heavy session, but I wanted to finish this today, so I stressed it by 15 more minutes. So you guys just now go do a lot of work. All these sessions will be, all the 5 sessions on the past, in this series, they will be hosted on our internal portal very soon. And all the new joinees who have joined already and have the access to our internal portal will seamlessly be able to access that. But for all the new joinees which are going to join us in the month of June, I will work out with our HR to how to get you guys an access to that. Thank you very much. I hope you guys have enjoyed.
Thank you, sir.